A Carnegie Institution for Science audio press release for June 2, 2015. Greenhouse gas-caused warming felt in just months. The heat generated by burning a fossil fuel is surpassed within a few months by the warming caused by the release of its carbon dioxide into the atmosphere, according to new work from Carnegie's Xiaochun Zhang and Caldeira, published in Geophysical Research Letters, a journal of the American Geophysical Union. The release of carbon dioxide into the atmosphere contributes to the trapping of heat that would otherwise be emitted into outer space. When a fossil fuel is combusted, heat is released. Some of this is used to make electricity or heat human-built structures, but eventually all of that energy escapes into the environment and warms the planet. But this combustion process also produces carbon dioxide, which is a greenhouse gas that accumulates in the atmosphere for thousands of years and traps heat that would otherwise escape into space, causing global climate change. In a modeling study of coal, oil, and natural gas, Zhang and Caldeira compared the warming caused by combustion to the warming caused by the carbon dioxide released by a single instance of burning, such as one lump of coal, and by a power plant that's continuously burning fuel. They found that the carbon dioxide-caused warming exceeds the amount of heat released by a lump of coal in just 34 days. The same phenomenon is observed in 45 days for an isolated incident of oil combustion, and in 59 days for a single instance of burning natural gas. Caldeira says that ultimately the warming induced by carbon dioxide over the many thousands of years it remains in the atmosphere would exceed the warming from combustion by a factor of 100,000 or more. For a power plant that's continuously burning, the warming caused by atmospheric carbon dioxide exceeded the heat released into the atmosphere by combustion in less than half a year, just 3 months for coal plants. With this kind of steady, continuous combustion, it takes 95 days using coal, 124 days using oil, and 161 days using natural gas. Caldeira explained that if a power plant is burning continuously, within 3 to 5 months, depending on the type of power plant, the carbon dioxide from the power plant is doing more to heat the earth than the fires in its boiler. As time goes on, the rate of burning in the power plant stays the same, but the carbon dioxide accumulates. So by the end of the year, the greenhouse gases will be heating the earth much more than the direct emissions from the power plant. Zhang added that it's important to note that heat emissions from combustion are not negligible, particularly in urban areas. But carbon dioxide-caused warming is just that much greater. Our results drive home the urgency of cutting emissions immediately. This chart shows the ratio of warming from accumulated atmospheric carbon dioxide to warming from combustion for coal, oil, and gas plants over time. The figure is simplified from Zhang and Caldeira's paper. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.